Hi everyone. Now we will talk about the confidence and prediction intervals for multiple linear regression. So remember, what is our path? Okay, so don't get lost. So first, what we do is we just fit a model and find and estimate and find the parameters. Estimate B0, B1, Bk. So we found a model. Then remember, we talk about its notation, how to find B0, B1, and so on and so forth. But then we talk about how to choose models. Okay, choose among models, right? Choose models, right? We will talk about some additional criteria on choosing models, but now assume that we just choose our model. So our model is okay. And now the third step is just make predictions, okay? Make predictions or make inferences, right? For what? For the unknown future responses, for the unknown future responses, okay? Responses, right, right. So this is our third step. By the way, in fact, we also have, so in fact, here we have something like this. So just check whether your model satisfy your assumptions or not. Satisfy assumptions. Remember, what was our assumptions? We said that, well, all of the epsilons are normally distributed with zero mean and some sequence. So if it doesn't satisfy, if there is a clear violation of the assumptions, then we just go back, maybe choose another model, fit another model, and so on and so forth. So again, we will talk about this satisfying assumptions, let's say, step. But now assume, okay, everything is fine, the assumptions are satisfied. Now let's try to make a prediction and inference for the future responses. Okay. So there are, remember, two things. The first one is the confidence interval. So I have something like this. So y is equal to beta 0 plus beta 1 x1. So let's write our model where you have three x's, beta x2, beta 3 x3, right? In fact, this is plus epsilon. So remember this part. So what I'm trying to do is finding this part, estimating this part, which is B0 plus B1 x1 plus B2 x2 plus B3 x3, right? So this part is in fact is equal to y hat. And remember, this y hat is a kind of x bar, okay? Is a kind of x bar. But x bar changes at every value of x1, x2, and x3, okay? So, this is x bar, a kind of x bar. Okay, this is a kind of x bar. So in fact, this part is also mu. Okay, mu of y, but given at some x, or let's say x0. So in order to find the mu, you should be given some x values. Okay, because your mu changes at every different x value. So what I'm trying to do is to find an estimate and interval for this mu, okay, which is this one or which is this one, right? So the first thing is, let's find the confidence interval over this mu. And the next thing is, remember, confidence interval is for a parameter, which is this one here. And we will also have a prediction interval, which is for a single response. Okay, so this is for a single response or individual response. Okay. So let me give you the, let's say, let me give you the formula for this. Okay, I don't get into the details, but well, the confidence interval for the mean response, okay, which is this mu of y. So remember, what was the confidence interval at the very beginning? Mu is in what? Mu is in x bar plus minus t alpha over 2 times what? S of x bar, right? S of x bar. So in fact, this one has the same structure. This is mu of what? Of y, but at some given x values, okay? So my x1 is given, my x2 is given at some value. So for example, we will see the example part. So what is the confidence interval where you just put 10% meat, 3% spice, and 15% vegetable? Okay, something like this. So let's say x30 is in this is what y hat, but I just put 0 in order to show that, well, it's something given. Okay, so this is y0 or y0 hat, so y hat or y0 hat, plus minus again p alpha over 2. So instead of the error, so the standard error of this, which is s of y0 hat, so this is what I have, s times what, x0 transpose x transpose x inverse x0. Okay, so what is x? We know x. X is the matrix that we have in terms of the values of the independent variable x's. What is x0? X0 is the value that is given to us. Okay, so what is the confidence interval for a 10%, right? Meat, 3% spice, and 15% vegetables. Okay. So remember our example. So this is my previous example. It just says, well, please construct a 95% confidence interval for the mean response when x1 is equal to 3%, when meat is 3%, when vegetables is 8%, and when the spices are put as 9%. Okay? Just find this thing. So just go back. This was my formula. Okay. So I will just try to put them. So the resulting regression line was this, okay, 39, 1.061, and okay, so we are just using the first model. I don't remove the third one. So assume that we are using the full model, okay? So what I do is, in order to find the corresponding value, I just substitute the values of x1, x2, and x3, okay, which is 3, 8, and 9. Okay, just look at it, 3, 8, and 9. So what is my x0? What is x0? So x0 is this vector. This is 1 because 1 is constant, okay? We always have 1. And the second one is 3, which is this, right? Which is this. The next one is 8, and the last one is 9. Okay? 1, 3, 8, and 9. Okay? This is my x0 vector. Okay? So what is this? This is x00. This is x10. This is x20. This is x30. Okay? So its point estimate is 24.2232. So if somebody asks, well, I don't want to see intervals, I don't want to see different numbers, just make an estimation, just make a prediction for me, a single point, then this is what you have. So if you just put 3% meat, 8% vegetables, and 9% spices, well, your like ratio of your food is almost 24%. Great. So the next step is just try to find this thing, okay, which is, remember, the key thing to find the standard error for the estimate y0 hat, okay, in order to find the s of this. So x0 transpose, which is this one, x0, okay, that's that value, and this is my x transpose x inverse. It's just calculated and given here, and the resulting thing is 0.1267, okay, 0.1267. So then the corresponding thing is, so first find t sub 0.025, so this is t sub alpha over 2, right? For 9 degrees of freedom, why? Because I have 13 many observations minus what? Minus k, which is 3, plus 1, okay? So this is 9. And okay, and S squared, remember S squared was 2.073 for this model, okay? And then the last step is just substitute the values, okay? So this is my S value, this is the T value, okay? This is the T sub 0.025, this is S, and this is the square root of, remember, x0 transpose x inverse times x0. And the resulting value is what? Your mean, so look at this, your mean with 95%, I am sure that your mean will be between 22.55 and 25.89. What does this mean? This says that, well, if you just put 3% meat, 8%, let's say, vegetables, and 9% spices, the average, the mean like ratio of this food will be between 22.55 and 25.89, okay, between these two numbers with 95% confidence. Okay, so its mean like ratio is between this and this, right? Okay, that's great. And the next thing, so this is for the mean response. Okay, it's average. So we don't say anything about a single food. So if you're just trying to prepare a food for this night, so what does this say? This says that, well, if you just keep making foods using this mixture, then on the average like ratio will be between this and this with 95% confidence. But if you're interested in, well, I'm just making a food with this percent, okay, for this night, I have some special guests this night. What will be the like ratio at this night? Okay, so you're just asking a particular point. Okay. Uh, okay, so this is what we are talking about the prediction interval. So confidence is on the mean response, and prediction interval is on an observed a single response. And just like remember, just like the previous cases where we just put 1 into prediction interval, again put a 1 here. Okay, so this is 1 plus x0 transpose x inverse x0, and here I have 1 here. Okay, again, I don't get into the mathematical details, but this is what you have in terms of the formula for the prediction interval. Right? The rest is the same. So for our example, what is a prediction interval? It turns out that it's between 19.25 and 29.2. Okay, so if you're just making a food, okay, let's say where you just put 3% meat, 8% vegetable, and 9% spices for this night, well, its like ratio will be between 19.25 and 29. Okay, so this is for, again, what? This is for a single observation. Okay, this is for a single observation. So, okay, you can just compare it with the previous case, right? Just look at this. This is much more wider than the previous confidence interval, where it was an interval for the mean response. Okay, and again, this is for a single response. Okay.